Hello, everyone. Welcome to this event that we have. We are very pleasure to participate in events with Sajjad Haidari. He wants to talk about, excuse me, reinforcement. Okay, it's UCB. Excuse me. UCB reinforcement learning algorithm in R. Before event, I really want that you participate in first name and last name. Please don't write abbreviation for your name. Please write completely your first name and last name to participate this event. Okay, welcome, and I want to hold this event for Nasrin, please.
Okay, thank you, Samone. Hello, everybody, and welcome to this event. We are very pleased to have Sajjad here, and he is a data scientist. Is one of the greatest companies in Iran. So we are very pleased to have him. He will talk about the reinforcement algorithms in R. And if you are okay, you can share your screen and stage is yours. Thank you so much.
Is it okay? Can you see
yes.
the slides?
Perfect.
Okay. Greetings and good evening to the participant of this event. Today we are going to talk about the reinforcement learning concepts and its application in our programming language. Briefly, I hope it is useful for all of you as participants. And if I want to introduce myself, I would say I'm Sajjad Haidari, and working as a data scientist for almost 5 years. And also I have a master's degree in industrial engineering, and really appreciate Dr. Nasrin and her team for providing this opportunity for me. So let's start to this webinar. In this webinar, we talk about various things, but at first, it is better to know some things about machine learning. The first question is, what is machine learning? To answer this question, we try to define ML. Considering IBM Institute's definition for machine learning, we define machine learning as a branch of artificial intelligence and computer science that focuses on the use of data and algorithms actually to imitate the way that humans learn and gradually its accuracy. In fact, in ML, our final goal is to improve the decisions of managers to have efficient services and fix their position in top-notch conditions. And furthermore, with that, they will be able to deal with issues by setting suitable strategies, gathering relevant information, and then tackling their problems and being in the competitive market. In better words, ML has a process that splits into 3 categories. Initially, we should gather relevant data sets actually from different sources, and after that, we go to the next part, which is called ML Brain. In this part, the data fit the algorithm, fit on the algorithm, and algorithms must answer 3 main questions. First of all, we have to answer what kinds of knowledge that we need, how results can be generated, and expected accuracy. You know, sometimes we expect perfect situation, but it cannot be possible because of some of irrelevant situations. You know, therefore, it is better to consider a threshold for our accuracy that is close to our business aims. When accuracy is higher, we won, and all of things that be accurate. Another thing I would like to mention that ML has the three main categories. Number one is supervised learning, number two is unsupervised learning, and number three is reinforcement learning. Supervised and unsupervised are the two of the most important sections for the machine learning, and giving some insights for businesses. But in this event, we concentrate on reinforcement learning. So the question is, what is the reinforcement learning? To tell you the truth, reinforcement learning is a simulation-based optimization method which relies on interacting agents and to find the optimal or near optimal solution. In the optimization field, we cannot reach to the optimal solution, and we reach actually on the near optimal solution, and because of that, we mention in this slide near optimal solution. In addition, RL comprises two main elements: the agent as a learner and the environment as a learning thing. You know, to describe better, consider a child that has a distance from a heater. When this child decides to decrease or her distance, she might feel the burning. Conversely, when she decides to increase her distance, she might feel cold. So it is a vital issue that we find the best distance in RL problems. When she burning or feel cold, she, as an agent, receives a negative reward, and when she is situated in a good distance, she receives a positive reward. To find a result, RL tries to maximize the sums of rewards, average sums of rewards of her actions to reach the utility point. It is really important for us. A useful thing that you should know, it is interaction of RL with the other fields. Consider a chess game, and in that we have two agents that want to reach the utility point. They give some various strategies to reach that point. RL helps them for the good result. Also, when companies want to recommend their services to their customers, RL, as a superhero, aids them to improve their services and develop their efficiency of their businesses. Assume that a user wants to buy a watch. When she or he chooses, the system tries to give a real-time feedback to find the best product close to the main one. To explain it practically, the agent does action and rewards happen in the environment. The right picture in this slide. I say that again. The agent does action and rewards happen in the environment. Finally, the product that has maximized reward is shown to the customer, and business can improve the quality of their service. Now, we should know about elements of reinforcement learning. RL has 5 main elements that we could know about them. Number one is agent. Agent is a learner and a decision maker. Consider an advertisement company. In this company, advertisement that could show to the customers can be considered as agents. And on the other side, customers, from one customer to infinite customers, can be the other agents that they are own strategies, and they are trying to reach at their utility point and have a better game. Number two is environment, where the agent learns and decides what actions to perform. These things occurs on the on on the space that is called environment. Number three is actions. Actions, a set of activities of the agents that can perform. And number four is a state. Bear in your mind that that child, when child is really close to the heater, his or her state is closest points of the heater, and the state will be changed in many positions and many situations. And finally, the number five is reward. For each action selected by the agent, environment provides a reward for agents, and it can helps the agent actually to reach to the utility. Like it or not, reinforcement learning deeply relies on math. That is to say, math is essential for being an expert in reinforcement learning, and especially in machine learning. Dynamic programming as an optimization technique is really essential for learning, reinforcement learning. And here in this slide, we have the general model of dynamic programming iterations. You can see the variables such as R, S, and A that describes reward, states, and actions in the time of T. And these variables will change in the next state, next actions, and next reward. Consider with the base of this equation, we can make a new one, which is called the Bellman equation. This is the base formula of reinforcement learning problems, and all of reinforcement learning problems for optimize the rewards need this equation. So let's go to the next concept of RL. In reinforcement learning, you have an important concept of concept that compares two things: exploitation and exploration. Environments in RL, in exploitation actually, our agents move into the deterministic environment. Environments in RL split into two categories: deterministic and stochastic. That is really related to two concepts that I mentioned. In exploitation, our agent moves into the deterministic environment, and all of her actions are certain without any doubt. In contrast, when our agent explores in the exploration concept, her actions occur in the stochastic environment or non-deterministic environment with probabilities, and you cannot guess her or his next move on the next stage, as you can see in the picture of this slide. As a real example, I would like to talk about real cases of reinforcement learning in the real world. I would like to talk about Netflix company. In Netflix, we have a recommendation system that works with the RL technique. Each movie in this slide that you can see that takes the maximum reward, and after that, it can recommend to the customers and improve their efficiency of the business and the other things. Another company that uses reinforcement learning is Uber. Uber as an intelligent transportation system company, we are able to they are able to employ reinforcement learning to find the best price for each trip, or try to minimize passenger waiting time and maximize the driver's revenue. This is really fantastic topic for academic papers and academic career to choose these topics and continue your career. Especially my academic career is related to dynamic pricing with reinforcement learning. Now, after getting familiar with the basic concept of reinforcement learning and its applications, it is better to move to one of the simplest algorithms in reinforcement learning, which is called upper confidence bound. To tell you the truth, in this algorithm, we try to find the maximum utility for naming as the best result. This makes an interval and calculates upper bound for each of actions of agents, and actually for sums of rewards of each agent. At last, the agent with the maximum upper bound choose for the final result and final result of to show the customers and improve the efficiency of companies. As you can see in this slide, upper confidence bound has 3 states for implementing on the paper. Number 1, stage 1, at each round, we consider 2 numbers of our agents. Agents can be advertisements, movies, a series, computer games, and all of things that can consider as agents. And we can define variable of n and r with the index of m that can describe separately is the number of agents and rewards of their agents can earn with changing the environment and their state. The stage 2 of this algorithm is defining the formula that can be calculated in 2 parts. In part A, the average reward can be calculated, and the next part we can make our interval, as you can see in this slide, with plus and minus of average reward with variable delta that can build with this situation. And the last part of the upper confidence bound, we use upper bound of the interval and use the final advertisement, movie or series or the other things, and show to the customer to have a better service. So in this part, although our programming has a lot of useful packages, we cannot use any of them to implement UCB and the other RL algorithms. So we have to make it from scratch. Because of that, I really like to go to the R Studio, and here's a sample code of implementing the UCB algorithm. As you can see, the number line 3 we have a data set, line 4, we have a data set that's called ads underline CTR underline optimization. In this data set, we have 10 advertisements. We as a advertisement company, and we have 10 advertisements that we like to show these advertisements to the customers, and our customers are 10,000 people with a lot of strategies, but we limit their strategies into two categories: dislike or like. Actually, our customers watch our advertisements, and finally they like or dislike them. So the line 6 are we implementing the UCB algorithm. Initially, we start to define N and D variables for our customer, for the number of our customers and advertisements, and initial variables that are called ads underline selected, numbers of selection, sums of rewards, and total rewards. That's they are equal to empathy list that we fill them in the other parts of implementing the UCB in the RStudio. From a starting point, line 14 to line 27, we have a for loop as a finite loop.
Sorry, you sharing your RStudio?
Yeah.
We can't see it. We see
okay,
your
okay.
presentation.
Okay.
Please share your whole desktop. Yeah.
Can you see it?
Yes. Now, please go ahead from the first.
Okay.
Thank you.
Okay. I say it again. We have a data set that's called ads underline CTR underline optimization .csv. In this data set, we consider as a company, advertisement company, and show to our customers 10 advertisements. And our advertisement and our customers that our customers really like to really like to watch our advertisements and like or dislike these things. So in this data set, we have 10,000 customers and 10 advertisements that we could show. With this situation, we have to implement the UCB for gaining the best results and having a maximum utility to a better service, for a better service, and have a worst advertisement, to find the worst advertisement and ignore it to the customers. From line 14 to line 27 in the RStudio, we have a for loop as a finite loop that we considered for our customers. And after that, as an expression of for, we define the variable of add and max upper bound as an initial variable for our first loop. And after that, our second loop is considered for our advertisements. In this for loop, we have to define our formula. So we use if else structure to employ some things and define our formula. First of all, we define our condition number of selections greater than 0, because number of selection is advertisement that's watched from customers. And after that, if advertisements watched from customers, that we can use it in our formula. So we define our formula in the below of our if structure, and else if number advertisements unwatched from our customers, we have to define our upper bound in the infinite number, because with this situation we consider our upper bound as an infinite number, and actually ignore it. And the second, if we use our upper bounds, our new upper bound that resulted from our formula, compared with max upper bound that's considered as initial variable. And after these for loop and if structures, we have to reach to the line 30. Advertisement selected, number of total variables or final variables to show the results of UCB algorithm. To be honest, the final result that you can use this result is total reward. First of all, we can use ads underline selected, and our advertisement, our selected advertisement is equal to this variable, and after that we can calculate our reward and sums of reward, and after that average sums of reward from selected advertisements. And in this problem, our aim is to find the worst advertisements instead of best advertisements. So I would like to say that total reward is the worst result that we have to ignore it and don't show to the customers. And after this code, we are able to actually illustrate our results in the histogram that you can see in the picture, in this picture actually. So let me take the minutes. Okay. As you see in this picture, we have a histogram of advertisements selected that's actually advertisement watched by customers. The longest histogram is the worst advertisement. When you see deeper on the picture, you will find the fifth advertisement that we consider as the worst advertisement, that we could ignore it and don't show to the customers. And conversely, we can find the best ones with this picture and reach to the final point and report to our manager for our aims. In conclusion, it is possible to say that reinforcement learning is one of the most complicated techniques in machine learning. If I could describe the future, I would say that RL can change everything in the field of data science, and you can use it in every sides of data science, and every businesses and companies need these complicated techniques for more efficiency, for more and the higher quality of their services and the other things. So this is the end of this event. I really thank you for your attention to me. If I have any questions, ask me, and I listen to you. Thank you.
Thank you so much. It was great. We are proud of you, first of all. It was a great event and we have learned lots of things. Let me see if we have any question from the attendees. If you have any question, you can unmute yourself and ask from Sajjad. Or if you want, you can type in the chat box. Any questions? I think we don't have any question. So
I think all of things is really clear for participants.
That's the point. Okay, if anybody, this is a great event from Mustafa. Thank you, Mustafa. So other comments? If you want, please, please open your camera. We can have a great picture from this event. Yes, someone. Okay, the other ones. Ali, Mustafa, Nagme.
Mahsa, please all everybody open your camera.
If you want, you can open your camera and we can have a great picture for this event. I think, okay, let me take a photo. Everybody, just a beautiful smile. Great. Okay, thank you again, Sajjad.
Thank you, Mr. Haydari. Very nice event, very nice presentation. Thank you. I hope you you see in the next time in the next events.
Yeah.
Thank you too.
Okay.
Thank you very much for providing me this opportunity to present the advanced topic of data science.
Very great. Okay, so have a great time, everybody, and see you. Bye-bye.
See you. Bye-bye. Bye-bye.